Good morning, dear students. Last session we have talked about this finding stress at a section in a pre-stressed concrete member when it is subjected to pre-stress by a concentric tendon and also by an eccentric tendon. So when you just recall, the concentric tendon is inducing axial stress. So we will be having same value of stress from top to bottom of the cross section. So top fibers and bottom fibers and all remaining fibers will have same value of stress if the tendon is placed at the center of the cross section. If the tendon is given some eccentricity, then the bending stresses also will come into picture. The reason why is that we will transfer this load to the center by a mechanism called load transmission. So by transmitting the concentrated force from one location to the other, you are going to have a load moment system. Okay, so instead of these two arrows we will have this moment arrow. So a load moment will act. So when axial load acts, this is the stress diagram. When a bending moment acts on the cross section, and this is the stress diagram, because it is going to bend the beam in a hogging manner. So top tension, so which is negative, bottom compression, which is positive. So combining these two, the final value of stress you can calculate by this formula: P by A minus PE by Z top at top, and P by A plus P into E divided by ZB at bottom. These are the resultant stresses at top and bottom due to eccentric tendon only, right? Now, and to get the final form of it, we have just replaced Z with I by Y and multiplied and divided by capital A, so that we will have a radius of gyration taken into picture, which is the property of the cross section. Square root of I by A, and I square will be I by A, just I divided by A. So both these properties are of sectional properties. Okay, moment of inertia depends on cross sectional area. Okay, so this is the final form of the uh, formula that you have to use for calculation. So F, I mean stress at bottom, you can see you have to use plus stress at bottom. This is stress at top, you have to use minus for pre-stress only, right? Okay, going for the next case. Okay, that means when that pre-stressing stage is over, means the beam is induced pre-stress, and then now the beam is transported to the site of construction, and it is placed in position, and now it is uh, taking the loads like dead load and live load. It is taking. So live load value say small q, dead load value say small g, So if these are the loads that are coming on to the cross section of the beam, then how do you calculate the final stresses in the concrete? Okay, so that is what we are going to see in this session. Okay, so beam is pre-stressed by a straight tendon. Okay, this is a straight tendon. You can have even a curved tendons also, having some kinks likewise, depending on the loads that you will be getting, right? So that we will see in the next discussion. So carrying a pre-stress force of capital P at an eccentricity of small e, resultant stresses in concrete at any section are obtained by just superposing the effect of each type of stress, like pre-stress and stresses due to loads. So this we have already calculated and know how to calculate from this formula. Now you have to add to this the stresses from live loads and dead loads. This is what you have to do. Okay, right. Let us see what will be the final form of formula. Right. First, calculate if you want stress, or the symbol if you use F. Okay. If you want stress value, we will use bending equation m by I F by y rho. So we need bending moment. So QL square by 8 is the, generally dead loads and live loads are UDL. Okay, in general. So UDL is going to cause this much moment at center. So QL square by 8. This is due to live load. And GL square by 8 is the moment due to dead load. Okay. So now the beam is having pre-stressing tendon and as well as loads also. Okay, service loads also. Now let us see how you calculate stresses in the concrete. So the tendon is placed eccentrically. So the concrete will have direct stresses P by A, also bending stresses P E by Z top and bottom. So this is due to pre-stressing tendon. Okay. Now coming to dead load, stresses due to dead load. So the beam, when it is supporting a dead load, okay, it is like UDL. So what is going to happen? It is going to bend like this. So the maximum bending moment occurs at center, and that value is this one. Dead load means GL square by 8. So that is this you will see M by Z. Okay, sigma is M by Z. Okay, this is what is this one. And you have to be careful with the sign convention. So the cross section is bending in a sagging manner. So top compression will be bottom tension. So top compression we will use plus symbol. Bottom tension we will be using minus. Okay, negative. Positive stress at top, negative stress at bottom due to dead load. Same way, live load also. They say there is some live load acting on it. That also is going to bend the section in sagging manner. So top compression, bottom tension is the nature of stresses developed. So live load bending moment MQ divided by Z will give you stress at top, and that is compression positive. Bottom MQ by ZB, M by Z. Okay. So due to live loads, and it is negative because of tension. And you can see that the both service loads are going to create tension at bottom, whereas the pre-stress is going to create compression at bottom, positive positive. So this is what we want exactly, to make the tensile stress either zero, or it has to be completely compression at bottom. Okay, this is what we wanted. So that is a purpose of pre-stressing. So if you don't have this pre-stress at bottom, and it will be tensile stresses at bottom, you will be designing for steel, okay, to place the steel at bottom. Now if you make these tensile stresses zero, you don't need to place the steel at bottom. Okay, this is what is the purpose of the pre-stress to induce in the concrete. Okay, so advantage of the pre-stressing member. Okay, so this is how it is going to, behave the section. So when you induce pre-stress, when you pull the tendon and create compression at bottom, tension in the top of the pre-stressed concrete member, it is going to bend in a hogging manner, right? So this is how it is going to bend. Whereas when the loads act on the member, it is going to bend down, exactly opposite nature. Okay, so this is what is the counteracting of pre-stress against the live load and dead load. Okay, and final form of the stress at top is this one, P by A minus PE by Z top plus mg by zt, means stress due to dead load, mq by zt, stress due to live load. Okay, bottom, if you see, p by a plus pe by zb minus mg by zb minus mq by zb, and you can see top compressive stress is high, bottom compressive stress is less. It can be either zero. This diagram may have zero stress at bottom, or even it can have a little tension also, a little tension also, so depending on this total value. So bottom, if the stress is zero, you will have a line joining this point, this point to joining this point. If it is having a positive value, the existing diagram. If it is having more of live load, heavy live loads, heavy dead loads, you will have negative value, little tensile stress. If you want, if you want, then the diagram will be like this. Okay, this line will be joining to this point. So when you have an still remaining negative, negative stress at bottom, then it will be uh, like little tension remaining. So we will be like designing a tensile stress also prevailing at the bottom. Okay, so that is what we will do in this bottom fiber stress. So there are three options. Either you may have zero stress at bottom, you may have positive stress remaining at bottom, and negative stress at bottom. So there are three such options. So these bottom having tensile stress, we will be calling them cracked sections, because without the steel, if you allow the tensile stresses in concrete, it is going to cause cracks. Okay, so this is the final form of stresses, resultant stress, when you have live loads and dead loads acting on it. Okay, so this is going to be the formula to calculate, and you have to be sure about these negative signs and positive signs. Okay, so this is like top, stress at the top. Okay, so the stress at top due to bending in pre-stress. Okay, it is tension due to pre-stress. That's why we use negative. Tensile stress is negative. And due to live load and dead load, top compression, so we use plus. This is bottom. So bottom compression due to pre-stress, that is why plus. Bottom tension sagging, so negative bottom tension due to live load and dead load. So this you have to be sure about these plus and minus signs, so that they are going to alter the value of, if you just fail to place the exact sign convention, maybe plus or minus. If you fail to do that, and you are going to end up with getting a wrong value of stress. Okay, so be sure, and easy to remember is pre-stress is going to have a hogging nature, and loads are going to have sagging nature. So this nature you can easily assess these directions, plus or minus, all that. Okay, this how the the pre-stressed member is going to uh, know act when the loads come onto the section. Okay, so you can see the clear advantage of pre-stress here, why pre-stress is required, and why the tendon should be at bottom only, below the CG line. Okay, all that is the necessity of the pre-stressing tendon to be at bottom, just to have opposite nature of bending and opposite nature of stresses to be developed uh, when compared to the live load and dead loads that are going to be taken up. Okay, right. So next session we will see an example. Okay, so that's all for this session. This the no complete information regarding analysis of pre-stress when you want resultant stress at top and bottom to be calculated uh, because of pre-stress, because of dead load, because of live loads coming onto the pre-stressing member. Okay, so this is the uh, required information to solve example problems available in your prescribed textbook. So take your prescribed textbook and solve for all such examples under this category. Right? Okay. Right. We'll see the example in the next session. Thank you.